Okay, we can start. Hi everybody. Thank you so much for coming. It's really just an honor and a privilege. I'm really loving this conference, having so much fun. So my name is Marco, and I am a senior software engineer for Bluefin Payment Systems. And today I would like to talk about microservices. Now, most talks and articles out there about microservices these days will try to sort of tell you all the good things about microservices and why microservices are so brilliant and incredible and why you should do it. And instead, what I would like to do today is to focus on something that microservices will not do for you, and that is that microservices will not improve your code quality. So firstly, we're going to look at why it's important as software engineers and in general as people producing software, why it's important to write the best possible code, the highest quality of code, no matter what and regardless of circumstances. And secondly, we're going to see why the monolith, which is the antithesis to microservices, is not that bad by definition. It's not really bad intrinsically, but there are ways to make it bad. There are also ways to make it good. And then thirdly and finally, we're going to see how microservices or doing microservices is not really an excuse to overlook the quality of your code and your software. And we'll see how all of this will kind of come together. So who of you knows how to count? 1, 2, 3, 4, 5. Who can do that? Hopefully everybody. Okay. Now, who of you is a proper mathematician? Got a degree in mathematics, something of that sort? Okay, cool. I guess if you are a mathematician, you know it. I'd imagine, right? So, I mean, if you've done your studies and everything, you probably know that you are a mathematician. So, how many? Probably there's 3 or 4 people. Okay. Interestingly enough, not everyone who can count is a mathematician. That's probably not very surprising to you, and it's obviously kind of obvious because knowing how to count is just one sort of practical aspect of a much larger set of skills and a much larger profession, a much larger discipline, which is mathematics. So if you are a mathematician, it's not just about knowing how to count. There's a lot more there that you need to know. And being a mathematician, just like every other profession, involves, for the most part, 2 kind of elements. And the first one is the theory, so all the stuff that you learn from the books, and you just have to know it. A lot of it, you actually have to know it off by heart. If you are, say, a computer scientist, you can't go around not knowing what a CPU is. It's just one of those things, you have to know it. There's no way around it. Or sooner or later, they'll find out that you're not a real computer science, and they'll fire you, if you're even as lucky as to get a job. And then there's the discipline, which is, for the most part, is the type of, it's those things that you learn kind of on the job, or at least by being surrounded by people that have more experience than you, and they just tell you, okay, that was all the theory that you learn. Those were all the data, all the concepts, all the notions. Now here's how we experts apply this stuff. And I can't think, to be honest, of any profession that doesn't require both sort of elements. Something that you have to learn theoretically, and then just being surrounded by other people and you learn how they actually apply that. So it won't come as a surprise to you that having seen the case of being a mathematician, it won't come to you as a surprise. As just as knowing how to count doesn't make you a mathematician, knowing how to write code doesn't make you a programmer or a software engineer. It's not just writing code. So being a programmer is a profession, and that involves a much sort of larger set of skills and abilities and qualities and best practices and disciplines that you have to know, you have to master in order for you to become a programmer or a software engineer. I mean, let's face it, writing code, you go onto Code Academy, any of those websites, and you can learn how to write code. It's relatively easy. 2 to 3 months, even if you have no context, no background whatsoever in computer science, you can learn how to write some code. Now, does that enable you to go out there and write scalable code, maintainable, enterprise level, that will function, that will work? And I mean, that's obviously just not going to happen. It's not real. Like I said, like in the case of every other profession, being a programmer is a lot more than just that. And one of the things that being a programmer involves is the idea that it's not just about writing code, but it's also about writing great code. In other words, writing great code is essential. You don't just write code as it comes, but you aim at writing the highest quality, the easiest to maintain, the easiest to test, the most modular as possible type of code, the cleanest type of code, well-designed type of code. That is a measure of, as a software engineer, of how professional you are. And obviously, we don't have the time now for me to go into kind of all the details. That would be one or more presentations that could go just on that topic, on what are all the laws and best practices and rules and disciplines of what it means to write great code. But ideally, if you are in the software engineering field, you should kind of know that it's not just about writing code as it comes, but there's a few rules around it. So having established that, we can go now on to what is the real topic of this presentation, which is what you need to know before you even consider doing microservices. And we'll see how that will come together with what we've just said about code quality. So there's two things that you need to keep in mind before you even consider doing microservices. And those two things are, number one, that the monolith is not bad per se. So if you are going into the microservices kind of world, just because you believe that the monolith is bad kind of intrinsically, that is a problem. And the second thing is that microservices don't magically suspend the rules. The rules are still there, they still apply. So let's look at both of these topics more in depth. The monolith is not bad per se. Now, microservices these days obviously have become kind of like the fashionable thing to do. Everyone's talking about it, everyone wants to do it, everyone thinks it's the kind of the solution to all of humanity's problems. Now, don't get me wrong, I'm the biggest fan of microservices. I really like it, really enjoy it. I'm the biggest advocate. When possible, I like to encourage people, companies to do microservices, and NAMA actually made a good sort of organizational case for the use of microservices. But as mentioned, it is always about use cases. So it is not a silver bullet. There's cases when microservices make sense. There's other cases where the monolith actually make more sense. And of course, in this kind of wave now where microservices are being presented to us as the greatest solution to all of humanity's problems, there's people and companies who are making money out of selling to someone else microservices. And obviously there's nothing fundamentally wrong with that, but where the problems begins to sort of become evident is where these people will kind of push microservices to you, and obviously the moment you don't do microservices, they're not making money. So they have to convince you that microservices are good no matter what, and that the monolith is bad no matter what. And to do that, they'll try to paint you this picture of the monolith as being this big ball of mud, this really unmaintainable spaghetti code, just really, really bad. You do the monolith, inevitably you're going to end up in a really bad situation where your code, your software is just going to fall apart and it's never going to work. And that obviously isn't true. If you know a thing or two about software engineering, you know that you can write clean and good code no matter the architecture that you're using. And there are actually, in my view, some benefits to using the monolith. Microservices have a lot of benefits and advantages, but the monolith still retains a few benefits that to this day, and to my knowledge, microservices haven't been able to get to that point yet. One would be faster initial development. Obviously, I mean, no matter how easy it is becoming these days, and it is getting easier and easier to do microservices, you can't compare that with just going on to, say, Ruby on Rails or Spring or Symfony, whichever framework you use, if you're using a framework. You download it, you quickly write whichever business logic you're trying to kind of develop, and then you deploy it to production. There's nothing as easy as that. That is just really, really fast. Now, in the long run, it might not be super scalable. You might incur into organizational problems, of course. But from the point of view of a fast initial development, just being able to get the product out there quickly, the monolith is still, in my view, a better way to begin. Easy deployment. I mean, with the monolith, you have one artifact or one group of files or one executable. You take it, put it onto your production server, and it works. You run your server, you run your Apache Nginx or Tomcat or whatever it is, and you make it work, and it works. With microservices, well, not so easy. Think about network, think about how many servers, think about all sorts of things. Easy testing. Think about, especially from a QA point of view. I mean, obviously, it's not as kind of black and white, but ideally, the monolith is either up or down. The thing is either working or not. With microservices, there could be 3 microservices out of 20 that are not working, and you go onto, say, this website, and it still looks like it's working, and then there's 3 little parts of the whole application that are not working, and it's hard to sort of see that many times from a manual QA point of view. So in order for you to identify that, you need to develop, as Nama again was saying, some sort of automation and some more sophisticated way to test your software. Easy sharing. The monolith is probably all in one repository. You share the repository with the other developers, and you just start working on it. With microservices, most likely multiple repositories, most likely a bunch of different kind of configurations. It's not just about getting the code from the repository and making it work. Easier to secure. Obviously, there's a lot that could be said here, but just think about network considerations and things like that. Microservices that need to talk to each other over the network. You just don't have to think about that with the monolith. And obviously, I'm oversimplifying, but it is the reality. So what does that tell you? What's that telling us? It's that the monolith is really only bad if you let it. So if you write code in the best possible way, in a way that's modular, that's maintainable, that's testable, and you follow all the best practices of software engineering, the monolith still has its own advantages, and you shouldn't discard it. You shouldn't think that the monolith is bad per se, and anything that's done with the monolith will never work, no matter what. And then on to my second and last point. microservices don't magically suspend the rules. And the kind of main point around this idea is kind of the notion that micro doesn't mean less important. In other words, something that's small or micro in the case of microservices is not less important. You still need to put the same amount of care and attention for the details into a microservices as you would into a bigger monolith. I hear these days many people talking about saying things like, oh, we do microservices, therefore we don't really put nearly as much attention to sort of design as we used to do with the monolith. With the monolith, object-oriented programming and all sorts of things. You had to do all sorts of designs up front. Now with microservices, every time that we need a new service, which is write a bunch of just quick procedural code. We don't even test it. We push it on production. And if it doesn't work, it's such a small amount of code that we quickly tweak it and fix it and make it work on the fly. And eventually it will work. I think that if you've dealt with any real world application, you probably, real world platforms and customers, you know that this is just not true. You can't do that. You cannot push code into production that hasn't been thoroughly tested. And also, you don't want to push code that a developer 6 months from now can't even understand what's going on. There has to be an element of still maintainability and knowing what the code is doing and some thought and design behind it. And to give you an illustration of this, imagine you are a development team and a bank comes to you and says, can you guys build for us an online banking application? You say, fine, sure, why not? So you talk with your team and you decide to go for a monolith. You build this banking application as a monolith. Now, I'd imagine that one of the things that you would probably tell your team is, guys, this is extremely important. In other words, we're talking about money here. If there's anything important that we're ever gonna do, this is it. We can't mess up. If a client is ever going to use this application and he wants to transfer 50 euro to another account and we transfer 500 euro because there is one line of code that wasn't tested and the numbers are messed up and we kind of, and the thing doesn't work as it should, we're going to be in big, big trouble. Banks and a banking application is probably one of the most kind of difficult and one of the things that you need to put the most attention to when you building software because you're dealing with money, as I said. So you do it as a monolith and you put a lot of attention into it, super high test coverage, just make sure the thing works fantastically. You don't push anything until you are 100% convinced that it works. Now imagine a similar scenario, but instead, what you tell your team is, guys, we're gonna build this as a microservices system. So what you're gonna have is you're gonna have a bunch of little microservices, each one doing something else, something different, and they'll all talk to each other. So every single microservice would focus on one aspect of the sort of the broader business logic of this bank application. One of them could be the withdrawing microservice, the one that when you go to the ATM, you withdraw your money. Now, can you imagine thinking for even a moment that this is, because this is really small, then it's not that important? Can you imagine I go and try to withdraw money and I want to withdraw 50 euro and I get 50 cents instead? Can you imagine what type of reaction would that cause from your customers? This is a big, big problem. You cannot make that happen. So I guess the bottom line is that the withdrawing microservice, as small as it may be, has to be as accurate and precise and tested and perfect as the bigger monolith would have been. So we're not getting away from code quality, no matter what architecture we choose, no matter whether we go with the monolith or we go with microservices. We're not getting away with quality from writing good quality code. We have to do that. We have to keep doing that. So the bottom line is, don't do microservices if you think that something that's small is not important. It doesn't matter. You still should be a professional and do things the right way. Which brings us to the to our conclusion and to what I guess is probably a question one could ask here, which is what microservices are really about. Because if it's not true that microservices enable us to go faster and skip a lot of the old problems with the monolith, if that's not true, and if in fact microservices actually add a lot of complexity to our system and there's no escaping from still the quality, we still need to do that, code quality and all of that, then why exactly are we doing microservices? What are microservices really about? And a guy called Robert Martin, which probably most of you have heard of, also known as Uncle Bob, wrote these lines. He said, microservices are really more about the deployment strategy than anything else. And that, when you think about it, makes a lot of sense. But of course, it's not necessarily the narrative that we're getting these days from people who advocate microservices. Deployment strategy, what it means is that you could literally get to 70–80% of your development without even thinking about whether you're going to deploy it as a monolith or as microservices. What that means in practice is you build your software in a modular, clean way with interfaces talking to each other, clean interfaces, pieces of code that can be removed and swapped with each other. And then when you get closer to the time of release, you decide whether you want to deploy it as a monolith or if you want to deploy it as a microservices system. Now, obviously, there are differences. I'm not saying that you can literally do everything exactly the same and then just deploy microservices or monolith as if it was irrelevant. But it's probably just the last bit. So when you get to the last bit, you've got all your modules, all your components, the software is ready, it's working. Then the last bit is saying, okay, are these modules going to be all in the same server, or are they going to talk with each other with, say, for example, over the network and from different servers? And that would be more of a microservices view of looking at this. So what microservices really are about is a deployment strategy. It's not a quick shortcut for you to overlook the quality of your code. It's not a way to make it quicker or easier or faster to get your code out there. In fact, they actually add a lot of complexity, and they can help you from a deployment point of view because you can handle your resources better having microservices on different servers. And they can probably also help you from an organizational point of view because you can assign microservices to different teams. But they're not a way to accelerate the time of development by overlooking what are the best practices of the profession and the discipline of being a programmer. And that's all I wanted to say today. So thank you very much. And if you have any question, feel free to ask.
Go ahead. Marco, there's maybe it's quite a specific question. I've heard from my development teams that they're trying to make this architecture microservices sometimes, but for them, it's the most complicated problem how to represent or develop modules which need to produce aggregators, like for statistics. For microservices, we understand that it's very small service which give very simple information, piece of information. But aggregators, it's much complicated when you have to catch many services, many microservices and put it together.
Yeah.
So what we have to do? Just simple question. If it's, I understand that it's big.
Yeah. Well, yeah, as you said, it is a big thing. Obviously, I suppose there isn't one answer. I mean, there's obviously a lot of conversation going on about also how do microservices talk to each other. Initially, a lot of people were saying, "Oh, easy, let's do it over the network, over HTTP with JSON interfaces one to each other." And then, of course, you come to more complex use cases, and people start saying, "Okay, but then how do you handle asynchronous communication?" And then come into play queues and other, more just slightly more complex systems that you used for microservices to talk to each other. So. If you're not careful, and yes, absolutely. I think that in the end, the complexity of the system ends up probably being even worse. Now, again, it's all small components, so it's maybe from an organizational point of view, you can have small teams assigned to each microservice, so maybe that helps. But I'd say that microservices in general, and that's just my view on it, are more of a solution to the scalability problem than the kind of development workflow kind of problem, because that doesn't get easier with microservices. It probably gets harder. I don't know if hopefully that kind of gives you a few hints.
Supplement what you just said. First of all, thanks for the view. Really differs from what currently is on the market, because everybody is now passionate about this scene, and everybody's here saying, it's so cool. So very reasonable pressure. Though, as you said, you really like this technology and you really like this pattern. So when would you suggest to use it in terms of for example, what issues or what problems in an organization it should attack or it should fix? Means, for example, you're hearing, what I'm trying to get as an answer is, for example, when you hearing some trigger or some complaint from a customer who came for your advice, then you say, oh, okay, microservices are going to fix it. What it would be?
Probably if it's the customer complaining, then it's probably almost never the case that microservices will fix his problems, except maybe, except in the case of scalability. So if the complaint that the customer is doing is if he's saying this thing is really, really slow, then you probably could consider going into microservices as a solution. Okay. Yeah. Yeah. Okay. In that case, there's still, I think, an element of scalability, but also probably an element of teams organization. So let's put it this way. One thing that I always say is that, in my opinion, if the company is small and the team of developers is small, say, I don't know, 3, 4, 5 people, don't do microservices. Why would you do that? Even if you have maybe 10 people, I don't know if it makes sense. When you start getting much, much bigger, then you can consider doing microservices. Why? Because from an organizational point of view, you can have teams assigned to different microservices. So I think that helps a lot from an organizational point of view. Then again, if you know how to build good software, even the monolith should be built in a way that's clean and scalable and where things don't sort of mess with each other. So there is, I think, where we should be careful is where people tell us that the monolith will be a solution to the fact that we're struggling with our code. So if we're struggling with our code, if we have a problem, the code is just messy, difficult to maintain. Every time that we change something, it takes 6 months, because we should be really, really careful when people tell us, oh, the solution to that problem is microservices. Because it's probably not going to be, if that makes sense.
And actually, we are now undergoing, we are a company of 700 people, and we are now undergoing an architectural change to introduce microservices. And the reason for this was mainly organizational bindings. So we have a huge units, very heavy, very big, very monstrous, and we are not really flexible in more organizational regard. And this way we came to architecture. So yeah, this is like, I think, a very good use case. I've also like thought maybe something else, some additional use cases for microservices. But in general, yeah, thanks.
I would say, generally speaking, I'm obviously oversimplifying. Then you go and look at the specific company use cases. But in my view, generally speaking, it's either a scalability problem or kind of an organizational problem. It can never be a problem of the software isn't working or the software is too buggy, the code is it's difficult to add new features. If you have that problem with a monolith, you're probably going to keep having the same problem with microservices. Because what's that telling you is that, and this is really harsh to say, but it's probably that the engineers working for you aren't that good. And that's just how it is, unfortunately. Any other question? Do we have time? Okay. Going to lunch. Thank you, everybody.